Okay, so here I am with an example of Newton Raphson method that I have solved. So this is the example. The function is the f of x is nothing but exp minus x or e to the power minus x. This is my f of x. That will make f prime x as e to the power minus x minus 1. So here is that function f of x that is given as exponential minus x. Here is the f prime x that is minus exponential minus x minus 1. So let us say if I start with x old as 0. So in the first iteration I will calculate f of x, that will come out to be 1, f of f prime x, that will come out to be minus 1, and with the help of that Newton Raphson formula, that is x old minus f of x old upon f prime x old, that formula will give me x new as 0.5, and that will make error which is calculated as x new minus x old upon x new into 100. So this is calculated as x old minus f of x old upon f prime x old, while this is calculated as x new minus x old upon x new times 100, or you can take mod of it. So in the first iteration I get this. Now this x new will become x old for the next iteration. This x new have got this value. So I'll calculate the f of x again, f prime x again, then x new I will calculate again with this formula, and then I can see that the error has reduced to 11.7. Now in third iteration also this thing will keep on going, and as we can see at the sixth iteration we have achieved the true root via Newton Raphson method. This is the true root. As we can see that the function value is 0. If you remember, for the same example we could not reach the true root by 10th iteration by fixed point iteration method, but here in 6th iteration only we have achieved the true root. That means Newton Raphson method is faster. Newton Raphson method is faster as compared to other methods which we already talked. But here the problem is, so first, before going into the problem of Newton Raphson method, there are multiple problems subjected to convergence and divergence, uh, which you can go to the Chapra and Canal book and read about them. I will not be able to discuss about each of them in detail. I'm just giving you the gist of the method. If you want to know the details of when this method will fail or when this method is good, you can go and read the Chapra and Canal book. That is numericals method in engineering. I guess this is the name of the book, and it is given by it is written by Chapra and Canal. So now let us go back to the slide and let us do the error analysis. Analysis of Newton Raphson method. So that's what I want to do in this rest of the video. That's what I am looking to. Okay, so in the Newton Raphson method I have this Taylor series approximation. So I have this function f of xi plus 1 is equal to f of xi plus f prime xi plus 1 minus xi plus there must be f double prime xi upon factorial 2 xi plus 1 minus xi to 2 plus there will be higher order terms. Now this is order of x square. This is order of x square. Now remaining terms I am approximating. So I am writing it. Remember this, focus on this. Xi plus 1 is f of xi plus f prime xi plus 1 xi plus 1 minus xi plus f double prime chi upon factorial to xi plus 1 minus xi whole square. So this is what I am approximating, where chi belong to xi plus 1, chi is in between xi and xi plus 1. So the whole error, or I would say the terms after this term, are approximated by this. So essentially what I am saying, that we have written it down as f of xi plus 1 equal to f of xi plus f prime xi plus 1 minus xi whole square plus some error. Let us write down that. Now within each iteration we assume that we have reached the true root. So let us keep it as equation number 1. Now I am saying that within each iteration we assume that we have reached the true root. That means f of xi plus 1 is equal to 0, as well as since we are at the true root, we can say that this error is also taken as 0, because the first order approximation is giving me the true root. That's what I am assuming within each iteration. So that means what will become, it will become as 0 equal to, so here I should put an approximation sign. It is not exactly equal because there is an error involved. So here, so let us say if it will be equal, or if I do not take this as error, then this f of xi plus 1 is nothing but approximated value of f of xi plus f prime xi plus 1 minus xi to the power 2. Now since I am assuming within each iteration that this value is 0, which means 0 equal to f of xi, this is almost equal to, plus f prime xi plus 1 minus xi to the power 2. Now remember, this is my equation number 2. So what are my two equations? My first equation is f of xi plus 1 equal to f of xi plus f prime xi x minus xi2 plus error. This is my first equation. My second equation is 0 equal to f of xi plus f prime xi x minus xi power 2 xi plus 1 plus error, and that is giving me, this is xi plus 1. This is giving me equation number 2. Now I am saying that suppose xr is my true root. That means f of xr equal to 0 will become f of xi plus f prime xi xr minus xi to the power 2 plus error. Now this is my equation number 3. Now what I am doing, I am subtracting equation number 1 from equation number 3. or I am saying I am subtracting equation number 2 from equation number 3. This equation I am subtracting, and that will make it as um, that will make it as that will make it as 0 equal to f prime xi f prime xi xr minus x I plus 1. That will make it as, sorry, this thing will be of power 1. That's where I was getting confused, that why this thing is happening, and this thing will this 2 power is not there. Okay, so that's what the confusion was. So this thing will become f prime xi xr minus xi plus 1 plus, now if you know, we take that form, that f double prime chi upon factorial 2, then this will become xr minus xi power 2. Okay, so I will give you this error analysis in the next video, because I think I have sorted it out, but I would like to explain it proper to you. So this will make f prime xi, and this is nothing but error at iteration I plus 1 plus uh, f double prime chi upon factorial 2, and this is error at I whole square. That means we are saying that error at I plus 1, this is the true error. True error is the true root minus the current value. This is the true error. True error is I plus 1 equal to minus f double prime minus f double prime chi upon factorial 2, f double prime chi upon factorial 2, true error at iteration I divided by f prime xr. So this is what it means, that at the new iteration the error will be almost equal to so the error will be this f double prime xr upon factorial 2 f prime xr times the error square in the previous iteration. So this is what it means, that in the next iteration or in the current iteration, the error is this factor multiplied by the square of error in the previous iteration. That's what the error analysis from the Newton Raphson. I will give you this explanation properly in the next video. because there is a lot of mathematical jugglery in this, and I think I should find out my notes to check it out, that how the equations are proceeding. Although I have given you the gist of it, so this thing is not J, this is XR. So to properly explain it to you, I will give you the analysis in the next video. Okay, thank you.